Okay, so let's talk about solving a three-variable system here. All right, so we no longer just have two equations when it comes to our systems. So most of the equations that we are used to seeing, or most of the systems that are the norm systems, solving elimination methods, substitution, graphing, for the most part we deal with two equations. So this video is going to focus on doing a three-variable one. So three variables, three different equations that we need to solve here. Now, the preferred method to use here is to start with elimination method here. So essentially we're going to use elimination method a few different times, and then when we eliminate enough to where we solve for at least one of our variables, we're going to backtrack and substitute back in to figure out what our values are. So when we have an answer here, our answer is going to have three different variables in it. It's no longer just going to be an x and a y. We're going to have an x, y, and a z. So we are talking about three-dimensional here. We're no longer just talking about lines. We're talking about planes. So think maybe like the board or a sheet of paper. Instead of having a line like this, we're talking about planes across, whatever situation we're dealing with here. So these here represent planes, not just lines here. So we test out and see how are these going to intersect. They look all sorts of different ways. I'm not going to get into that right here. I'm going to get into the solving of this here. Now, the way that we solve this here, now, because there's a lot going on with this one here, I definitely always recommend that you keep this a little bit neat as far as what you're doing here. I like to label the equations. I label them 1, 2, and 3. And typically what I do is I kind of use my equation 1 kind of like as a control equation. So we need to use elimination method here in order to solve this. So the way that that's going to work is we're going to do a couple cases of elimination method. So what we're going to do is we're going to eliminate equation 1 and equation 2. And then we're going to eliminate equation 1 and equation 3. All right, so equation 1 is kind of like our control, our starting point. So we're going to deal with number 1 and number 2 first. Then we're going to deal with number 1 and number 3. And we're going to eliminate the exact same variable in both of those. So let me get this written down. So equation 1 is 4x plus 8y plus z. Then we have x plus 7y minus 3z is equal to a negative 14. And over here, let's see, we have equation 1 and then equation 3. So we're going to do elimination method for each one of these here, making sure that we eliminate the same variable in each. So I'm going to start at the end here and I'm going to eliminate z's. So I'm going to eliminate z's here and I'm going to eliminate z's here. It is important that you eliminate the same thing. Don't eliminate z here, then eliminate x over here or something like that. Make sure that it's the same variable. All right, so what I'm going to do here, if I need to eliminate z, so again, elimination method is where we want to add our equations in the hope that something cancels. Now, 1z minus 3z is a negative 2z. Nothing's going to cancel if I straight add these two here together. So I do need to multiply at least one of my equations by something. So since this is a negative 3, that means I want to make this a positive 3. Again, remember they need to have the same number but different signs. So what I'm going to do is I'm going to multiply the top equation by a 3 in order to make that what I need it to be. All right, so that means I'm going to have, well, let's see, 12x plus 24y plus 3z is equal to 6. And I'm just going to drop the second equation down. Or actually, you know what? Let me just add them like this. Okay? So this is the first equation. I multiplied it by 3. Now we can eliminate. We can add them together. Negative 3z plus 3z cancels. Otherwise, let's see. 1x plus 12x is 13x. 7y plus 24y is 31y. And this is going to equal to negative 16 plus 6 is equal to a negative 8. I'm going to call this equation 4. Now go over here and do the same thing. Take this equation and also eliminate z. So if I'm eliminating z, let's see, I have a 1 and a 2. So I need them to be the same number, different signs. So a 1 and a 2, the closest thing they have in common there is a 2. So, and I need one of them to be negative. So I'm going to multiply the top one by a negative 2. Negative 2 times 4x is a negative 8x. Negative 2 times 8y is a negative 16y. Negative 2 times 1z is a negative 2z. Is equal to negative 2 times 2 is a negative 4. Add these two equations up. 2x plus negative 8x, that's a negative 6x. Negative 3y plus negative 16y is a negative 19y. And 2z minus 2z, those cancel. 3 plus negative 4 is a negative 1. I'm going to call this equation 5. Now what we need to do is we need to take equation 4 and equation 5 and do elimination method with those. So what I'm going to do is I'm just going to take equation 5 over here and I'm going to put it right down over here below equation 4 so I can take a look at these two equations and kind of see what's going on here. So just because my x values over here have smaller numbers, I'm going to go ahead and focus on eliminating the x value here. Right? So we did elimination method with 1 and 2. We did elimination method with 1 and 3. And we got these two equations right over here. And we're going to do elimination method again. 3 equations in our system, 3 elimination methods that we're going to need to do. All right, so if I'm going to eliminate the x here, so let's see. We have a 13x and a 6. Okay, so let's take a look at how we're going to have to eliminate here. So looking at our x values, we have a 13 and a negative 6, so they already have different signs. The first thing 13 and 6 has in common, so 13, 26, 39, 52, so it's 60, blah, 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 blah. So let's see, I believe 78. 13 times 6 is probably the first thing that they have in common. So let's see, I'm going to do 13 times 6, and I'm going to do negative 6 times 13, and I'm going to distribute this and see what happens. So 6 times 13x is 78x. 6 times 31 is 186y. And 6 times negative 8 is equal to a negative 48. Distributing the bottom one gives me negative 78x minus, sorry, I'm pulling out my handy dandy calculator for this, 13 times 19 is a negative 247y is equal to 13 times negative 1 is a negative 13. Okay, so let's go ahead and add these up together and let's eliminate those x's. So 78 minus 78x, that cancels. 186y plus negative 247y there. So let's see, 186 minus 247, that's a negative 61y, is equal to negative 48 plus negative 13, that's a negative 61 also. Okay, so that works out great for us here because when we divide out the coefficient, so divide both sides by negative 61, and we get that y is equal to 1. All right, so what that tells us here is that, so if y equals 1, so remember, we're plugging in for an x, y, and a z up here, so we know that y equals 1, which means that we can now take that 1 and plug it in right up there. So we need to work on figuring out what is x and what is z. So what we're going to do at this point here is we're going to backtrack and substitute in to find the other ones. So go back up here, right, to either equation 4 or 5. Pick one of them. Doesn't matter which one. I'm going to pick the top equation. So I'm going to pick 13x plus 31y is equal to negative 8. And if y is equal to 1, we should be able to plug in 1 right over here, right, and solve for x. All right, so 31 times 1 is 31. All right, drop everything else down. Subtract 31 on both sides, and 13x is equal to negative 39. And when we divide both sides by 13, we get that x is equal to negative 3. All right, so now we can plug in a negative 3 for x. So we have our x, we have our y, we just need to find z now. So now what we're going to do here, and I'm going to erase some of this work over here. Now that we know what x is, now that we know what y is, we need to find z. So go back up here to one of your original equations and let's plug in our x and our y values. So I'm going to pick the top equation. Plus 8y plus z is equal to 2. So let's see, x is a negative 3 and y is 1. So I'm going to simplify this. 4 times negative 3 is a negative 12, plus 8 times 1 is 8, plus z is equal to 2. Negative 12 plus 8 is a negative 4. And when I add that 4 to both sides, z is equal to 6. So now I can plug in a 6 for z, and my final answer here is negative 3, 1, 6. This is a really big problem. There's a lot of room to make mistakes here. I think I made a couple of mistakes on my way when I was getting to this one here. So there is a lot going on, so do please be very careful when it comes to solving these here. But essentially the process is about the same. So label your equations. It's going to help you keep them a little bit nice and neat, right? And your first two elimination methods, you need to make sure you're eliminating the same thing. And then you can eliminate one more variable in that third one, and then just backtrack and plug and chug away to find those values. Okay, so negative 3, 1, 6. That's how you solve a system in 3 variables.